I change its shape. So as I keep on increase applied force, the normal contact will shift. Finally, what happens? The normal contact is the maximum possible displacement it can have, no? And the weight of this mg will act. Then it can topple about point P. So the net torque about point P. For the block to topple, or we'll put it here, no? Should be 0. So what about the torque by applied force? F into H clockwise, mg into B by 2 anti-clockwise. So this F is equal to how much? mg B by 2H. If you apply force greater than this, it will topple. If you apply force less than this, it will not topple. The similar idea, that's the same thing. What we had idea of the triangular, there's a condition for triangular plate. So you should bother about that n, because the n cannot shift beyond point P. There's a maximum permitted. So earlier, if you remove this force, where n will act here. As you start applying, as you start increasing force, the n will shift. What is the maximum permitted value of shift of n? B by 2. That's what I'm writing here. So about point P, I'll apply torque. Torque due to applied force F into H mg B by 2. If the applied force greater than this, the triangular block will topple. If the applied force less than this, it will not topple. And now, so this is about next rigid object. What all we discussed toppling for rigid object. Why rigid object only? Because if you take plastic or elastic, what happen? There will be displacement of points, no? So therefore, this toppling is better, is confined to only strictly a rigid object. The body should be rigid. If it's not a rigid, any problem?